When you step outside on a clear night and lift your eyes, you are not seeing the universe as it exists right now. You are looking directly into the past. Every photon striking your retina has traveled a distinct distance across the void, meaning the sky above you is a collage of different eras. The moonlight left the lunar surface just over a second ago. The light from the sun is 8 minutes old. But the glow from Sirius, the brightest star in our night, began its journey nearly 9 years before this moment. You are standing in the present, yet your vision is anchored deep in history. This time delay effect stretches violently the farther you look. The Andromeda Galaxy, that faint smudge visible to the naked eye on dark evenings, sends us light that departed 2.5 million years ago. When those photons began their voyage, early hominids were just learning to shape stone tools on the African savanna. Entire species have risen and fallen, continents have drifted, and ice ages have come and gone while that light was in transit. We are essentially cosmic archaeologists. Our telescopes are not magnifying glasses, they are time machines that let us excavate the history of creation layer by ancient layer. Consider the pillars of creation in the Eagle Nebula, made famous by the Hubble telescope. Those towering columns of gas and dust, stretching light years tall, are stellar nurseries where new suns are currently igniting. Yet the light revealing their majestic structure took 7,000 years to reach us. In a twist of cosmic irony, a shockwave from a nearby supernova likely obliterated those pillars 6,000 years ago. We are watching a ghost, a magnificent structure that hasn't physically existed for a millennium, preserved only by the finite speed of light. The universe shows us its baby pictures long after the children have grown and the house has burned down. Even the seemingly peaceful act of star birth is rooted in violence and collapse. Inside a molecular cloud, gravity fights a desperate battle against thermal pressure. When a region becomes dense enough, it fragments and collapses inward, spinning faster like a figure skater pulling in their arms. Temperatures at the core spike to 10 million degrees, igniting nuclear fusion. The resulting radiation pressure blasts a cavity in the surrounding cloud, halting the infall of material. What we see as a colorful nebula is actually a battlefield, ionization fronts eating away at dust, stellar winds carving bubbles, and jets of superheated gas punching through the darkness at hundreds of kilometers per second. Beyond the stellar nurseries, the variety of worlds defies old science fiction. We have confirmed over 5,000 exoplanets, and the catalog reads like a fever dream. There are hot Jupiters orbiting their stars in days, their atmospheres boiling away into comet-like tails. On WASP 76b, it rains molten iron on the night side. On 55 Cancri E, a super-Earth hugging its star, the surface is likely a global ocean of lava beneath a sparkling atmosphere of silicate vapor. Then there are the temperate worlds in the habitable zone, like those in the TRAPPIST-1 system, where 7 Earth-sized planets orbit a dim red dwarf, potentially tidally locked, offering a permanent day side and an eternal night side. This sheer scale forces a recalibration of human significance. In 1990, Voyager 1 turned its camera backward from the edge of the solar system, capturing Earth as a pale blue dot suspended in a sunbeam, less than a pixel wide. Carl Sagan noted that everyone you love, everyone you know, everyone you ever heard of, lived out their lives on that mote of dust. All our wars, ideologies, religions, and economies play out on a stage so small it vanishes against the backdrop of the Milky Way's 400 billion stars. And our galaxy is just one of 2 trillion in the observable universe. The distance to the nearest large galaxy, Andromeda, is so vast that light, the fastest thing in existence, needs 2.5 million years to bridge the gap. The future of observation pushes against the ultimate horizon. The James Webb Space Telescope, parked a million miles from Earth, peers into the infrared to see the first galaxies assembling just a few hundred million years after the Big Bang. It watches the cosmic dawn, the era when the fog of neutral hydrogen cleared and the universe became transparent. But even Webb has a limit. Because of the accelerating expansion of space driven by dark energy, distant galaxies are receding faster than light can travel. There is a cosmological event horizon beyond which we will never see, no matter how advanced our instruments become. The universe is slowly, inevitably, disappearing from our view. So why look up at all? Because in that act of looking, the universe wakes up. Hydrogen atoms forged in the first 3 minutes of the Big Bang, fused into carbon and oxygen in dying stars, scattered by supernovae, and assembled into a brain capable of wondering about its own origins. That is you. You are the cosmos becoming conscious. Every time you trace the arc of the Milky Way or spot the steady glow of Jupiter, you are closing a loop 14 billion years in the making. The darkness isn't empty, it is deep time made visible. Keep watching. The story is still being written in light.